Okay, in this video I'm going to talk about the derivatives of hyperbolic functions, and if time allows I'll go ahead and cover the derivatives of inverse hyperbolic functions in the same video. If not, I'll add another video. So let me just give you the formulas. Here's the formulas for hyperbolic functions. Now if you don't know what they are, you can see my lecture in the Cal 1 notes on hyperbolic functions, or you can do your own research online or use a textbook. So this is the derivative of the hyperbolic sine of u is actually going to equal the hyperbolic cosine of u times u prime. The derivative of hyperbolic cosine of u is going to be, the derivative of that's going to be hyperbolic sine of u times u prime. The derivative of hyperbolic tangent u is going to be hyperbolic secant squared of u times u prime. The derivative of hyperbolic cotangent u is minus hyperbolic cosecant squared u times u prime. The derivative of hyperbolic secant u is minus the hyperbolic secant of u times the hyperbolic tangent of u times u prime. And finally, the hyperbolic cosecant of u, the derivative of that would be minus the hyperbolic cosecant of u times the hyperbolic cotangent of u times u prime. So beside each of these, I actually gave you just a little example here. So let's take a look at them one by one. So here I have the hyperbolic sine of, actually I've got this notation wrong here, so I shouldn't have this equal. I should have y prime equals that. So hang on, let me fix that first before I move further. Okay, I think I cleaned it up now. Okay, so we've got the function here, y equals the hyperbolic sine of x squared. So this would be the hyperbolic sine of u, where u is x squared. So the derivative of that would be hyperbolic cosine of u times u prime. So here's what I have here. So since u is x squared, I'll write hyperbolic cosine of x squared, and then I have to multiply by the derivative of the x squared, and the derivative of the x squared is just 2x. Okay, so again, the derivative of the hyperbolic sine of x squared is hyperbolic cosine x squared, and then times the derivative of x squared, which is 2x. Now the next one here, I have y equals the hyperbolic cosine of 5x. So the formula for the derivative of hyperbolic cosine of u is hyperbolic sine of u times u prime. Well, the hyperbolic sine, so the derivative of this would simply be hyperbolic sine of u, and since u is 5x, I'd have hyperbolic sine of 5x, and then I would multiply by the derivative of this 5x, and the derivative of 5x is 5. Okay, and then this formula here, I'll need this formula for this one here, the hyperbolic tangent of sine x. Now again, that's not a product, that's the hyperbolic tangent of the argument sine x. So what's the derivative for the hyperbolic tangent of u? Hyperbolic tangent of u is hyperbolic secant squared u times u prime. So I would write the hyperbolic secant squared of u and u is sine x, right? And then I would multiply by the derivative of u, and since u is sine x, the derivative of sine x is cosine x, so I'd multiply this by cosine x. And then the next one, I'll need this formula because I have the hyperbolic cotangent of 3x squared. Well, the hyperbolic cotangent of u is actually minus the hyperbolic cosecant squared of u times u prime. So if you're wondering where the minus comes from, it's from the formula. So there's the minus, and then you have the hyperbolic cosecant squared of u. Remember, u is 3x squared in this case, and then you multiply by the derivative of 3x squared, and the derivative of 3x squared is 6x. Okay, and then the next one here, I have the hyperbolic secant of e to the x. So in this case, u is e to the x. So what I'm going to do here is the formula for hyperbolic secant is actually minus hyperbolic secant of u times hyperbolic tangent of u times u prime. So I have the minus hyperbolic secant of e to the x times hyperbolic tangent of e to the x, and then times the derivative of e to the x, which is e to the x. And of course the minus comes from the formula that has a minus there. And then the next one is hyperbolic cosecant of u is minus hyperbolic cosecant u times cotangent u times u prime. And so again you have a minus, and so that's why there's a minus here. And so the u in this case is natural log of x. So the derivative hyperbolic cosecant of natural log of x would be minus hyperbolic cosecant of natural log of x times hyperbolic cotangent of natural log of x, and then times the derivative of the natural log of x, and the derivative of natural log of x is 1 over x. So there you had one for each of those functions, and here's a couple more down here. For hyperbolic sine of x cubed minus 1, hyperbolic sine of u, the derivative is hyperbolic cosine of u, and then times the derivative of u. And since u is x cubed minus 1, then the derivative of x cubed minus 1 will be 3x squared, and I'll just write the 3x squared here. And then now this one is not a hyperbolic. This is actually a natural log. So this is actually the natural log of u. So don't get tricked on this. So the natural log of u, remember what the formula is for natural log of u? The formula for the derivative natural log of u is what? It's 1 over u, so it's going to be 1 over this hyperbolic tangent here, and then multiply by the derivative of the hyperbolic tangent. So because that's the u here. So it's 1 over u and then times the derivative of u. So it's 1 over hyperbolic tangent, whoops. So it's 1 over hyperbolic tangent of x and then times the hyperbolic secant squared of x. Okay. Now actually I use some identities here, and you can go through that arithmetic there and see that tangent 1 over hyperbolic tangent is the same as hyperbolic cosine over hyperbolic sine, and then hyperbolic secant squared is the same as 1 over hyperbolic cosine squared, and then you can cancel one of the hyperbolic cosines and you end up with 1 over hyperbolic sine times hyperbolic cosine. Or another way to write that would be hyperbolic cosecant of x times hyperbolic secant of x. So anyway, that one required a little bit of identity work here. And then this one is really nothing particular here. I mean, this you just say, okay, the formula for hyperbolic cosecant of x using this formula up here would be minus hyperbolic cosecant of x times cotangent x, and then I just threw in another term, e to the 5x, and you know the derivative of e to the 5x is just 5e to the 5x, so you just tag the minus 5e to the 5x on at the end. Now in a calculus course you'll actually learn, you may not learn this, it depends on your instructor and how deep they want to go into hyperbolics, but hyperbolic functions actually have inverses. So there's the inverse, this is the form that you write for the inverse hyperbolic. So this is the inverse hyperbolic sine of u. This is the inverse hyperbolic tangent of u, inverse hyperbolic secant u, and so forth. And again, if you want to read more about them, then you can research that on your own. I'm just here to just show you the derivatives. Now each of these has their own little formula for the derivative. So the derivative of hyperbolic sine of u is u prime over the square root of u squared plus 1. The derivative hyperbolic cosine u of the inverse hyperbolic cosine u is u prime over the square root of u squared minus 1, and so forth. So what I'm going to do is I'm just going to do a couple of these. So if you take a look at my function here, that's the inverse hyperbolic sine of e to the 2x. So in that case, I know that u is actually e to the 2x. Okay, so if I want to find the derivative of this, I'll go up to this first formula here, right here, and I'll say, okay, it's going to have u prime in the numerator. So that would just be the derivative of this. So the derivative of e to the 2x is 2e to the 2x. And then in the denominator, it's going to have u squared. So if you square e to the 2x, you're going to get e to the 4x, and then plus 1. Of course, that's in the radical as well. So you're going to have the square root of u squared, and so when you square e to the 2x, you get e to the 4x, and then, of course, you have plus 1. So that would be the derivative of this particular function. Okay, now on this one, on this next one here, we have inverse hyperbolic cosecant of natural log of x. So in this case, u would be natural log of x, because that would be the argument of that. So now let's look for the formula for inverse hyperbolic cosecant. Looks like it would be this one here. So the formula here, so in the numerator I would put minus u prime. Okay, what is u prime? Well, if u is natural log of x, then u prime would just be 1 over x. So since I do minus u prime, I'll have minus 1 over x here in the numerator. And then in the denominator, I have an absolute value of u, so that's going to be absolute value of natural log of x. And then times the square root of 1 plus u squared. So that would be 1 plus the natural log of u quantity squared. And you can actually move the x to the denominator. So I'm going to go ahead and do that. So move the x to the denominator, and you get minus 1 over x times the absolute value of natural log of x times the square root of 1 plus the natural log of x quantity squared. And again, I could have shown you some examples that corresponded to each of these, but it's just a matter of applying the right formula to the particular function that you're given. In the next video, I'm actually going to show you a way that you can take the derivative of a function that's raised to another function. So we'll see that in the next video.